I know we've done this before, but I thought this is 2025's version. This bedtime lesson is the exact same as last time, like last year. It's about thunder and lightning again. A thunderstorm is a series of sudden electrical discharges. These discharges result in sudden flashes of light and trembling sound waves, commonly known as thunder and lightning. These discharges result of flashes of light and trembling sound waves, commonly known as thunder and lightning. They are associated with convective clouds and are often accompanied by heavy rain or hail. Now there's going to be about 4 or 5 parts to this lesson, so this might be like a part 2 in this one. So first of all, what causes thunder and lightning? Thunderstorms develop when the atmosphere is unstable. This is when warm air exists underneath much colder air. Now what causes lightning? As warm air rises, it cools and condenses, forming small droplets of water. If there is enough instability in the air, the updraft of warm air is rapid, and the water vapour will quickly form a cumulonimbus cloud. Typically, these types of clouds can form in under an hour. As the warm air continues to rise, the water droplets combine to create larger droplets which freeze to form ice crystals. As a result of circling air in the clouds, water freezes on the surface of the droplet or crystal. Eventually, the droplets become too heavy to be supported by the updrafts of air and they fall as hail. As hail moves within the cloud, it picks up a negative charge by rubbing against smaller positively charged ice crystals. A negative charge forms at the base of the cloud where the hail collects, while the lighter ice crystals remain near the top of the cloud and create a positive charge. The negative charge is attracted to the Earth's surface and other clouds and objects. When the attraction becomes too strong, the positive and negative charges come together, or discharge, to balance the difference in a flash of lightning, sometimes known as a lightning strike or lightning bolt. The rapid expansion and heating of air caused by lightning produces the accompanying clap of thunder. Now, where do thunderstorms form? Thunderstorms are common occurrences on Earth. It is estimated that a lightning strike hit somewhere on the Earth's surface is approximately 44 times every second, a total of nearly 1.4 billion lightning strikes each year. Owing to the fact thunderstorms are created by intense heating of the Earth's surface. They are most common in areas of the globe where the weather is hot and humid. Land masses, therefore, experience more storms than the oceans, and thunderstorms are also more frequent in tropical areas and higher latitudes. In the UK, thunderstorms are most common over the East Midlands and the South East. The next one is about thunder. Thunder is the sound produced by the rapid heating of air by a lightning strike. The word thunder is derived from the Thor, the Norse god of thunder, known for his ability to forge thunderbolts. There we go. Essentially, thunder is the sound produced by lightning. When lightning strikes, the narrow channel of air through which it travels reaches temperatures of up to nearly 30,000 degrees Celsius, almost instantly. This intense heating causes the air to rapidly expand outward into the cooler air surrounding it, creating a rippling shock wave, which we hear as a rumbling thunderclap. Like that. Depending on its formation and location, this thunderclap can be heard as either a sudden loud crack or a low long rumble. Thunder lasts longer than lightning due to the time it takes for the sound to travel from different parts of the lightning channel. The intensity and type of sound heard by the listener depends upon the conditions of the atmosphere and how close the listener is to the lightning. The louder the thunder, the closer the lightning is. When a lightning strike is too close, the thunder is heard as a loud clap or snapping sound. When a sound of thunder has a rumbling quality, it is the sound waves reaching the listener at different times owing to the shape of the lightning strike. In rare cases, the sound of thunder at very close range has been known to cause injury to humans and damage to property. Now, how far away is it? Thunder will always be heard after a lightning strike is seen, owing to the fact that light travels significantly faster than sound. Both the thunder and lightning thunderclap are generated simultaneously, but with the speed of light at 299,792,458 meters per second and the speed of sound at 340.29 meters per second, there will always be a gap between the two of the observer. Your distance from a thunderstorm can be estimated by measuring the time between seeing the lightning flash and hearing the start of thunder. The length of this interval in seconds can be divided by 3 to give an approximate distance in kilometers. Sometimes lightning may be seen, but there is no thunder. This is either because thunder is rarely heard more than 20 kilometers away, or because the atmospheric conditions lead to sound bending upwards and away from the surface. Our third part is about lightning. I know we said this before. As tiny water droplets form inside a storm cloud, they are propelled towards the top of the cloud by strong internal winds called updrafts, where they turn to ice. Some of the pieces of ice grow into hail, but others remain very small. Some of the hail that forms become too heavy to be propelled by the updrafts and so begin to fall back through the cloud, bumping into small ice particles as they do so. During these conditions, electrons are transferred to the hail, giving the hail a negative charge, whilst the ice particles that have lost electrons gain a positive charge. The updrafts continue to carry the ice particles upwards, giving the top of the cloud a positive charge. The hail continues to fall through the lower part of the cloud, giving it a negative charge. As well as being attracted to the positive charge in the top of the cloud, the surplus of electrons in the cloud base are attracted to the positive charge in other clouds and on the ground. If the attraction is strong enough, the electrons will rapidly move towards the positive atoms. The path they make in doing so forms the channel we see during a flash of lightning. As negative charge builds up at the base of cloud, the electrons near the ground surface are repelled. This leaves the ground and objects on it with a positive charge. As the attraction between the cloud and the ground grows stronger, electrons shoot down from the cloud, cutting through the air at around 270,000 miles per hour. Lightning flashes and strikes. Hold on a second. One minute. There we go. Although often assumed to be the same thing, there is a key distinction between the lightning flashes and strikes. A lightning flash is what you can see, but this is often made up of several individual lightning strokes, which are pulses of current which occur separately if they're only hundredths of a second apart. The term lightning strike refers to cloud-to-ground lightning, where lightning strikes the ground. A bolt from the blue. Most lightning strikes originate from the negative part of a cloud. However, occasionally a strike can come from the positively charged top part. This is called positive lightning. When positive lightning strikes, it is forced to go around the negatively charged base of the cloud. This generally results in a more powerful lightning strike which shoots out sideways and sometimes can travel a mile more away from the storm cloud before connecting with the ground. The nature of this type of lightning strike is where the term gets the term a bolt from the blue. Detecting lightning. Being able to detect the location of thunderstorms is often of great importance, as it is not only the lightning strike that is dangerous, but many other factors linked to thunderstorms. These include intense rain and tornadoes. When lightning strikes, it sends out pulses of radio waves, and these can be used to detect lightning strikes. These pulses are known as spherics and are capable of travelling great distances. because they are reflected between the surface of the Earth and a layer of the upper atmosphere called the ionosphere, in a similar way to light travelling within a fibre optic cable. An individual sensor is able to detect a spheric, but important to determine a thunderstorm's exact location, a network of sensors is required. For example, the LEELA system network of 11 sensors positioned around Europe. When a strike occurs, the network of sensors will pick up the spheric at slightly different times, and through a technique known multilateration, these readings can be used to determine the exact location of it. The difference is the time taken from the spheric to reach one sensor relative to another is called the ATD, arrival time difference. There's some other types of lightning. First one, ball lightning. A rare form of lightning, which is a persistent and moving luminous cloud. White or coloured sphere is seen. Rocket lightning is a very rare and unexplained form of lightning, in which the speed of propagation of the lightning stroke is slow enough to be perceptible to the eye. Pearl necklace lightning. A rare form of lightning, also termed chain lightning or beaded lightning, is which variations of brightness along the discharge path give rise to a momentary appearance similar to pearls on a string. Ribbon lightning. Ordinary cloud-to-ground lightning that appears to be spread horizontally into a ribbon or parallel luminous streaks when a very strong wind is blowing at the right angles to the observer's line of sight. The most common one, fork lightning. It is lightning in which many luminous branches from the main discharge channel are visible. Sheet lightning, the popular name applied to cloud discharge form of lightning in which the emitted light appears diffuse and there is an apparent absence of a main channel because of the obscuring effect of the cloud. Streak lightning is a discharge which has a distinct main channel, often tortuous and branching. The discharge may be from cloud to ground or from cloud to air. Time for part 2 of this lesson.